Hello my viewer, it is an honor having you on board. This is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Please join me for this lesson, learn, understand and enjoy maths with me. If you are new to our channel, please remember to subscribe to be our student and get our future lessons immediately they are released. To all my viewers, hello and welcome to today's lesson. In this lesson we are going to learn how to rationalize the denominator. To start with, let us have a definition whereby we are going to say that rationalizing the denominator is a process of writing a fraction containing irrational numbers in the denominator in a form that the denominator will contain only rational numbers. The techniques for rationalizing the denominator apply the following algebra concepts. 1. Root of a is also equals to a raised to power a half. Idea number 2, if you have root of a everything squared, this is equals to root of a multiplied by root of a, which can further be written as root of a squared. And since root of a is the same as a to power a half, this can be written as a to power a half everything we square it. And by third row of indices, this is equals to a raised to a half multiplied by 2, which is equals to a to 1. Number 3, for a plus b into a minus b, this is the third quadratic identity which will yield a squared minus b squared. The techniques for rationalizing the denominator are therefore demonstrated below. The first case is the fraction of the form a over b multiplied by root of c. What we're going to do for us to remove the square root from the denominator, we are going to take, we have a over b multiplied by c. We multiply the numerator and the denominator by the term in the denominator, that is we multiply here by b multiplied by root of c, and in the numerator we multiply by b multiplied by root of c, and this one will give us, in the denominator we have b multiplied by b multiplied by root of c multiplied by root of c, whereas in the numerator we have a multiplied by b multiplied by root of c. We simplify and we're going to get ab root of c divided by b squared multiplied by root of c squared, which simplifies to ab root of c divided by b squared multiplied by c. In that category, we look at our first example where we have 3 over 5 root 2. What we're going to do is we have 3 over 5 root 2. We multiply the numerator and denominator by the term in the denominator. So we multiply here by 5 root 2, and in the numerator we multiply by 5 root of 2, which will simplify to 3 multiplied by 5 root 2 divided by 5 squared multiplied by root of 2 multiplied by root of 2, which is equals to 15 root of 2 divided by 25 multiplied by 2. This is equals to 15 root of 2 divided by 50, and we can divide by 5 here, we get 3, by 5 here we get 10, hence simplifies to 3 over 10 root of 2. In the second category, we have the fraction of the form a root b plus c root d over e root f plus g root h. The value of a, c, e and g can take any natural number, whereas b, d, f and h are any irrational numbers. For us to simplify this, we are going to use the idea a plus b multiplied by a minus b will give us a squared minus b squared. And in our case, we can take now the root values. We are going to have root of a plus root of b multiplied by root of a minus root of b. This one is equals to root of a everything squared minus root of b everything squared, and this will simplify to a minus a b. That is the idea we are going to use to remove the surds from the denominators. By taking the different values of a, c, e and g, we have the following examples. Note, for a minus b into a plus b, then we refer a minus b as a conjugate of a plus b, and a plus b is therefore a conjugate of a minus b. The first example in this category, we have 3 over 3 root 7 minus 2. So what we're going to do is we consider the denominator 3 root 7 minus 2, and we determine its conjugate, whereby we are going to have the conjugate of 3 root 7 minus 2 is equals to 3 root 7 plus 2. Hence, we multiply the numerator and the denominator by this conjugate. We're going to have 3 multiplied by 3 root 7 plus 2 over 3 root 7 minus 2. We multiply by its conjugate. We have 3 root 7 plus 2. In the numerator, we open the bracket and we're going to have, this is 9 root 7 plus 6. Whereas in the denominator, this is a difference of 2 squares. We are going to have 3 root 7 squared minus 2 squared, and this will simplify to 9 root 7 plus 6 over 9 multiplied by 7 minus 4. On simplifying the denominator, we have 9 root 7 plus 6 over 63 minus 4, which is the same as 9 root 7 plus 6 over 59. The second example under this category, we have 4 over 2 root 3 minus root of 13. We have our denominator is 2 root 3 minus root of 13, and its conjugate is 2 root 3 plus root 13. We multiply the numerator and the denominator by this conjugate, and we're going to get 4 multiplied by the conjugate, 2 root 3 plus root of 13 over 2 root 3 minus root 13 multiplied by 2 root 3 plus root 13, and this one will give us 2 root 3 squared minus root of 13 squared, while the numerator reduces to 8 root 3 plus 4 root of 13, which further simplifies to the numerator remains 8 root of 3 plus 4 root of 13, whereas the denominator reduces to 4 multiplied by 3 minus 169, which is the same as 8 root 3 plus 4 root 13 over minus 157. Our example number 3, we have root 3 plus 2 root 5 over 3 root 3 minus 2 root 7. We have our denominator is 3 root 3 minus 2 root 7, which imply that its conjugate is 3 root 3 plus 2 root 7. We multiply the numerator and the denominator by this conjugate, and we're going to have root 3 plus 2 root 5. We multiply by the conjugate 3 root 3 plus 2 root 7. This term we divide by 3 root 3 minus 2 root 7. Multiply that by 3 root 3 plus 2 root 7. The denominator will simplify to 3 root 3 square minus 2 root 7 square, whereas the numerator will have root of 3 into 3 root 3 plus 2 root 7. We multiply that one by plus 2 root of 5 into 3 root 3 plus 2 root of 7. We simplify the numerator and the denominator separately, and we're going to get 3 root 3 multiplied by 3 root 3 plus root 3 multiplied by 2 root 7 plus 2 root 5 multiplied by 3 root 2 plus 2 root 5 multiplied by 2 root 7. We divide by, this is 9 multiplied by 3 minus 4 multiplied by 7. We still simplify, and we are going to get the numerator 3 multiplied by 3 plus 2 multiplied by root of 21 plus 6 multiplied by root of 10 plus 4 multiplied by root of 35 divided by 27 minus 28. Hence, we're going to have 9 plus 2 root 21 plus 6 root 10 plus 4 root 35, everything divided by minus 1. In the third case, we have the fractions added in case 2. They are either added or subtracted, but the special case is the denominators are conjugates of each other. In that case, we're going to use the idea if we have A over B plus C over D. Our first case, we're going to determine the denominator, where we have our denominator is BD, and we multiply the first set by D so that we have AD. We multiply the second set by B so that we have plus CB. That is the idea we are going to use for questions that are in this case. Our first example is 4 over 7 root 5 plus 3 root 2 minus 2 over 7 root 5 minus 3 root 2. We realize that 7 root 5 plus 3 root 2 and 7 root 5 minus 3 root 2 are conjugates of each other. Hence, if we multiply the two of them, the root sign is going to be eliminated. Therefore, we use the idea. We have our LCM is we multiply the two denominators, 7 root 5 plus 3 root 2. We multiply by 7 root 5 minus 3 root 2. We multiply this part, we multiplied by 7 root 5 minus 3 root 2, whereas when we come to this case, we multiply by 7 root 5 plus 3 root 2. Hence we have 4 into 7 root 5 minus 3 root 2. When we come to the second one, we have minus 2 into 7 root 5 plus 3 root 2. We simplify the numerator and the denominator separately, where we are going to get the numerator become difference of two squares, 7 root 5 squared minus 3 root 2 squared, whereas the denominator we are going to get 28 root 5 minus 12 root 2 minus 14 root 5 minus 6 root 2. And on further simplification, the denominator we get 749 multiplied by 5 minus 9 multiplied by 2. The numerator we are going to get 14 root 5 minus 18 root 2. Further, we simplify that one to 2. The denominator simplifies to 227, and the numerator simplifies to 14 root 5 minus 18 root 2. This is Dixon again from Maths Wiz. It is my hope that you have learned, understood and enjoyed the lesson. Please remember to subscribe to our channel and give us your feedback from the lesson. Thank you for your watching.